In this video, I'm going to go through a few of the quizzes that we have taken up to this point, and while the versions will be different that you take in the future, the ideas are all exactly the same. What you need to know is the same, so hopefully this will help prepare you if you've been struggling. Quiz 14 is parallel theorems and angle pairs. So all of the theorems that we'll be looking at in this quiz and that are from this section of our text start with the idea that I've got two lines that we know are parallel, right? That's what those little red arrows mean. And they're being crossed by a third line that we call a transversal. Okay? So two parallel lines, and we usually say it this way, two parallel lines are cut by a transversal. And so before I move on and look at this actual problem, I want to go to our theorem sheet. This is something that you are allowed to use during the quizzes. I will give you a copy of this if you need it. In order to use this, we need to remember our angle pairs from section 3.1, and there's a bunch of material there. We spent a lot of time on that. If you don't know the angle pairs that I'm talking about, these four right here, you need to go back and learn those first. Okay, so once we know these angle pairs, we can look at our diagram, and this will tell us how they're related. So for example, corresponding angles. If two parallel lines are cut by a transversal, then corresponding angles are congruent. Okay, so that means they are the same. They have to be exactly the same size. And remember, you have access to this on the quiz. So let's go back and look at that quiz now, okay, because we're going to be kind of referencing these theorems as we go. So it says, find the measure of the angles and state the theorem that you used. In other words, how do you know? So the measure of angle 1, and this is exactly what we were just looking at. This is an example of corresponding angles. So this pair right here, angle 1, is a corresponding angle with this 150. And that rule we just looked at tells us corresponding angles are congruent. So the angle of measure 1 must be 150 degrees, and this is the corresponding angle theorem. And I know it might be hard to see, but theorem is written down there. You don't need to write it twice. Okay? So that's how this works. That's how this entire quiz works. You need to know these angle pairs and how they're related, and that will let you make the connections that you need to make. So again, this angle 2, you could go about this one a couple different ways. Now, 1 and 2 are what we call vertical angles. Okay, we have that x, and they're on opposite sides of that x. So you could state that rule. Okay, and this is also 150 then, because vertical angles are congruent. So you could say because of vertical angles. Or you could relate it back to the 150 because this is one of our special pairs as well. These are what we call alternate exterior angles. So you could use the alternate exterior angles theorem. Struggling a little bit here. Alternate exterior. So a couple different ways you could do that, okay? So in the other versions of this, you'll have different angle pairs, but it's all going to be based on those same theorems that we know. Okay? This is the other type of problem here. Now this is going to take a couple of steps. So it's asking you to find the value of x, show your steps, say how you know. I am going through this quickly, so if you need to pause and digest this or watch it twice, that's totally normal. Okay, do that if that's what you need to do. So I need to find the value of x. So in order to do that, I need to know the measure of this angle or how it relates to another angle. And right now, you're not given any of our special pairs, but these two are one of our pairs. And that 1 is kind of there as a hint, like, oh, if I can figure out this 1, then I can connect these two together, and I can set up an equation that will allow me to find x. And so what I'm hoping that students notice is these two, again, are that vertical angle pair. And our rule says, this is on the theorem sheet as well, vertical angles are congruent. So you could start by saying something like this. The measure of angle 1 must be 123 degrees because I have vertical angles. So now that I know this is 123, now I need to recognize this is one of my special pairs. Okay, these are what we call consecutive or same side interior angles. And if you look back at that theorem sheet, it's going to tell you that these angles are supplementary, meaning they add up to 180 degrees. So our equation we could set up is 2x minus 3 plus 123 must equal 180. And we know that because consecutive interior angles theorem. And then we just solve that equation. Okay. All I did there is just combine these two terms. Negative 3 and a positive 123 gives me 120. Subtract 120 from both sides. 2x equals 60. Divide both sides by 2x equals 30. Okay, and I'm not going to go through the algebra of that because that part should be review, and there are resources if you're struggling with solving equations as well. So that is quiz 14. Moving on to quiz 15. This is the same angle pairs. We're just working in a different order, and this is really important. This kind of throws some students off. So let's look at those theorems just real quickly. Okay, these are the corresponding, these are the converse of all of the original theorems, which means it's just working in reverse order. So what this is saying, okay, in the previous section, we started with if two lines are parallel, then I know this special angle pair are congruent. Now when we switch orders here, and I'm using these converse theorems, we're saying if I've got these two lines, so two lines, and then there's a transversal that goes through them, and I know that those corresponding angles are congruent, then I can prove that the lines are parallel. Okay, so we've switched the order of the information in the theorem. And that's really important because that means I can't use any of these theorems up here because these all assume that the lines are parallel to begin with, and these theorems down here allow us to show that the lines are parallel. Okay, so if I don't know that the lines are parallel, I can't use these theorems that assume that they are parallel. And again, I know this is something that students can struggle with a little bit, so take some time and read through these and think through that again if necessary. Okay. So, number one, find the value of x that makes those lines parallel, right? So what value of x would make it so that these are parallel? And again, the first question is a little bit shorter, a little bit easier. We're given one of our angle pairs. These are alternate exterior angles. And if you go back at that theorem sheet, it's going to tell you if these angles are congruent, then the lines are parallel. So what I need to be true is I need 102 to equal 4x plus 6. And then that value of x will make those lines parallel. Okay, so this is the alternate exterior converse. And then I just solve for that value of x. Subtract 6 from both sides. So you've got 96 equals 4x. Divide by 4, x equals 24. One theorem, one equation, set it up and solve. Here we get slightly more challenging. I'm given these two, and it's asking me if they are parallel. And I need to make sure I explain how I know. So again, I can't say like, oh, this must be 56 because corresponding angles are congruent. We don't know that. Okay, so I can use some other theorems that are like always true. So for example, like vertical angles, like these two are what we call vertical angles. So this isn't really going to help us, but I know that this would be 56 because they're vertical angles. Something that would help us would be this angle right here. Okay. I can figure that out because I've got a straight line that's being divided into these two angles. Okay. And this is what we call a linear pair because together They are a pair of angles that make a straight line. And we know that angles that are a linear pair have to add up to 180 degrees. Okay, that's something that is always true. It doesn't matter whether lines are parallel or not. So I'm going to give this angle a number just to help me kind of express my thinking here. So I could say the measure of angle 1 has to be equal to 180 minus 56, which would be 124 degrees. And I know that because they are a linear pair. Okay. Notice I don't have to write all the words. If you just write this out, I will understand your thinking and you are fine. Okay. So angle 1 is 124 degrees because I've got a linear pair. And now I can make a connection using one of my converse theorems. Okay, now I have corresponding angles. And that theorem says if corresponding angles are congruent, then the lines are parallel, and they are. Okay, so maybe I'll just call this angle 2. Say the measure of angle 1 is equal to the measure of angle 2. So yes, the lines are parallel. By the corresponding angles converse. So that's the kind of thinking that we're going to need to go through. And again, notice it's really important that you recognize these angle pairs so you can make that connection. And if you don't remember how they're related, that's fine because you have the theorem sheet to tell you, but you have to notice and be on the lookout for those angle pairs. Okay. All right, moving on. Let's look at these last two, 16 and 17. Okay. 16, so we're finding slopes and determining whether lines are parallel or perpendicular. This should be mostly reviewed. There's only one tiny new idea in this quiz for us. Okay, and I'll get to that in just a second. First, we're going to find these slopes. So 4 different lines. I'm going to start with this line, which is line AB. Okay. And so if you're on a graph, you can just count, meaning I've got a nice intersection here. Probably even better to use this point because I'm telling you what that coordinate is. And so remember, slope is use that letter M, change in y over change in x, or y2 minus y1 over x2 minus x1 if we're using coordinates. Okay, but I'm just going to count here because I can. So from this point to this point, my change in y, which is my up and down, I went 2, 3, 4. I went down 4 and over 6. Okay, so this is going to be a -4 since we're going down. My change in y is a -4. My change in x is a +6. So this is -4 over 6, which we should really reduce to -2/3. And we're going to do the same thing for these other lines. Okay, and I'm going to show you this version in just a second. So on these lines, I'm just going to count. Okay, so CD, I'm going down 1, 2, 3, 4, 5, and over 1, 2, 3, 4, 5, 6, 7. Okay, so that is a slope of -7 over, nope, did I flip that? I think I flipped that. 2, 3, 4, 5, yeah. -5 over 7. Okay. EF, so I'm going down 1, 2, 3, 4, over 1, 2, 3, 4, 5, 6. So again, -4 over 6, which is the same as -2/3. And then GH, so from G to H, I'm going up 1, 2, 3, 4, 5, 6, and over 1, 2, 3, 4. Okay. So up is a positive y value, and to the right is a positive x value. So this is up 6 over 4, which is the same as 3 over 2. Okay. So I've got my 4 slopes. Which lines are parallel? How do you know? Okay. This is one of our 2 new things. Lines with the same slope are parallel. Okay. Same sign, same numbers. 1, 2. Okay. These lines are parallel. They will never cross. They have the exact same slope. So we would say line AB is parallel to line EF because they have the same slope. Okay. You could also use notation AB is parallel to EF if you want to shorten things a little bit. Which lines are perpendicular? Second thing that is new here. Perpendicular lines have slopes that are what we call opposite reciprocals. And this is an example right here. Okay? If we look at these 2 fractions, the fraction flipped, meaning I've got 2 over 3 and now I've got 3 over 2. And it also changed signs. One of those fractions is positive, the other one is negative. So this is an example of perpendicular. And what we say, the mathy term for that is those slopes are opposite reciprocals, where opposite refers to the sign and reciprocal refers to the flipping of the fraction. And you really need to say both. Okay? So technically we've got 2 pairs here. So AB is perpendicular to GH and EF is perpendicular to GH. And we know this because the slopes are opposite reciprocals. And if you can't remember that fancy term, you can just tell me the fraction flipped and the sign changed. That's enough. If you can show me that you understand it, that is enough. Okay? Finally, finding the slopes. And in this one, I'm asking you to specifically use that y2 minus y1 over x2 minus x1. And remember, that's just, I've got 2 coordinates here, which each have an x component and a y component. So 5 would be like my x1, and then this is my y1, x2, comma, y2. Just plug in and simplify. So this is -2 minus 1 over -3 minus 5, which is -3, trying to write too fast here, over -8. Okay, and when we simplify this, and we should, because a negative divided by a negative is a positive, we should really write this as +3 over +8. That is the most correct answer. Okay, if there's 1 negative sign, that means that the slope is negative. If there are 2, negative divided by a negative is a positive number. Hey, I'm not going to go through this for 17. If you look at the video for the notes, there are 4 examples of us doing exactly this. And if you need extra practice, there's extra practice posted in Google Classroom. This is something you just need to learn the process and practice it enough to do it.